What if I told you our entire universe was inside a black hole? That the Big Bang wasn't really the beginning, but actually the result of something collapsing in another universe? As wild as it sounds, some scientists seriously think this could be true. Today we're going to explore one of the most mind-blowing ideas in modern physics, and what it might mean about where we came from and what's really out there. So let's start simple. When a huge star runs out of fuel, it collapses under its own gravity, and if it's massive enough, it becomes a black hole, a region of space where gravity is so strong nothing can escape, not even light. At the centre of a black hole is something called a singularity, where everything gets crushed into a singular point, or at least that's the traditional view. But some scientists think there's more going on. Maybe the collapse doesn't end in a singularity. Maybe, just maybe, it bounces back, creating something new. So let's rewind to one of the biggest mysteries in science, the origins of everything. According to the standard model of cosmology, our universe began about 13.8 billion years or so ago in a hot, dense explosion known as the Big Bang. Space itself expanded from what seems like a singular, infinitely small point, and this is what scientists call a singularity. But here's the problem. We don't really understand what a singularity is. In fact, it might not even make physical sense. It's where our maths breaks down, a place where gravity becomes infinite, space and time no longer behave normally, and all the known laws of physics collapse. So that's where the black hole idea comes in. One physicist, Nikodem Popławski, forgive the pronunciation, I've always struggled with that, proposed a bold alternative. What if the Big Bang wasn't the start of everything, but the result of something else ending? He uses a version of Einstein's general relativity that includes something called torsion, a twist or spin in the fabric of space-time. Normally, general relativity talks about how mass bends space. Torsion adds an extra ingredient, the idea that matter can twist space too. This might sound abstract, but it has huge consequences. In this model, when a massive star collapses into a black hole, the torsion that comes from the spinning particles, like electrons and quarks, builds up and creates a kind of quantum resistance. Instead of compressing into an infinitely small point, the matter reaches a minimum size and then bounces. Imagine squeezing a spring as tightly as you can. Eventually it's going to push back, so that's the bounce. And as the result of that bounce, a brand new universe, like ours. So the Big Bang might not have been a singular explosion from nothing, but a rebound from a collapsing star, one that formed a black hole in another universe. You can kind of think of it like cosmic recycling. To observers in the parent universe, it looks like a black hole formed, but from the inside, from our perspective, it looks like a brand new universe expanding from a tiny point. And that changes everything. It means the Big Bang wasn't the beginning of all things, just the beginning of this particular bubble of reality we live in. It suggests our universe might be the interior of a black hole, and that there might be many more like it, each with their own laws, their own histories, and maybe even their own intelligent life. If our universe was born inside a black hole, that opens up a wild possibility. What if the black holes in our universe are also giving birth to new universes? Think of it like a cosmic nesting doll. Each black hole could be seen as a brand new universe with its own space, time, and even its own physical laws. This isn't just sci-fi speculation. The math behind certain versions of Einstein's equations allow for so-called baby universes to form. When matter collapses inside a black hole, instead of shrinking down to a point of infinite density, a singularity, it could rebound and expand somewhere else entirely. In that moment, from the outside, we see a black hole. But from inside, it could look like a Big Bang. So next time you hear about a black hole swallowing a star, imagine this. Somewhere on the other side, a new universe could be taking its first breath. So let's go back to our own universe's origins, the Big Bang. Traditionally, it's thought of as the moment when time and space themselves began, a sudden expansion from a point of unimaginable density and heat. But there's a problem with that idea. Singularities, by definition, don't make physical sense. They're where the laws of physics break down. It's as if the universe throws its hands up and says, I've got nothing. But if the Big Bang was actually the result of matter bouncing back from a black hole in a parent universe, then we don't need a singularity. Instead, we have a bridge, a way to connect the before and after. This could also explain some weird things about our universe, such as why it seems so uniform in all directions, or why the laws of physics are so finely tuned for life. Maybe those inequalities were inherited from a previous universe through the black hole that birthed ours. In this view, the Big Bang wasn't the beginning, it was a transformation. If we are inside a black hole, what does that mean for how we understand space? Well, from the outside, black holes are regions where nothing, not even light, can escape. But from the inside, space and time continue to stretch and evolve. It might not feel any different to us because everything, our planets, galaxies, and even our clocks are expanding together. And if you're wondering, wait, shouldn't we feel something weird if we're inside a black hole? The answer is no. According to general relativity, space can be curved dramatically without us noticing, as long as we're all inside that same curve. It's like being on a plane in smooth flight. You're moving at hundreds of miles an hour, but you feel like you're sitting still. So in this theory, our universe could be the calm, quiet interior of a cosmic storm that we can never see. So if we're inside a black hole, does that mean there's an edge to our universe, like a wall or a boundary? Well, not exactly. Just like on Earth, where you can walk in a straight line and eventually loop around the planet, the universe might be curved back on itself. There may be no edges, only endless space shaped in a way we can't fully picture. But that actually raises more questions. Could we detect the parent universe? Could signals leak through from the outside? Could we ever somehow escape? Most physicists say probably not. The boundary of a black hole, the event horizon, is a one-way door. Once inside, you're cut off from the outside world. So if we are in a black hole, we may never know for sure. But just because we can't observe something directly doesn't mean the idea has no merit. After all, for decades we couldn't see black holes either, and now we're taking pictures of them. If this theory is true, it changes the way we think about everything. It means the universe didn't pop into existence from nothing. It means our universe may have a cosmic parent, and it suggests that creation isn't a one-time event, but a cycle. One universe gives birth to another, possibly forever. And it could even hint at one of the answers of one of the biggest questions in science: why the universe has the laws it does. Maybe each universe inherits or slightly modifies the rules of the one before it, like biological evolution but for physics. Think about it, natural selection but for universes. Maybe the reason our universe supports life is because only universes with just the right laws can last long enough to create complexity and black holes, and those black holes give rise to more universes with similar traits. It's not just a poetic idea, it could be a testable. Some physicists have proposed there may be ways to look for this kind of cosmological natural selection. So are we living inside a black hole? Well, the truth is we don't know for sure. But the idea isn't as far-fetched as it sounds. It's grounded in real science, built on solid math, and supported by some of the smartest people on the planet. More importantly, it forces us to rethink about what we know. And it forces us to think about what we know about reality. Because the more we learn about the universe, the stranger it seems. And sometimes those strange ideas turn out to be right. Maybe, just maybe, black holes aren't the end. Maybe they're the beginning of something even greater. So what do you think? Could our entire universe be hiding inside a black hole? Let us know in the comments. And if you want to dive deeper into big questions like this, don't forget to like, subscribe, and hit the bell. There's a whole universe to explore, and we're just getting started.